Here we are asked to graph y equals x squared plus 2x minus 8, then use the graph to solve related inequalities. All right, so to graph this function, I will find the vertex and intercepts and use that to graph it. All right, so I know that this is a parabola. The graph is a parabola. I know it's going to open up since the lead coefficient 1 is positive. Let's find the vertex. Well, the x-coordinate of the vertex is given by negative b over 2a. So negative, my b value is 2, and my a value is 1. So 2 divided by 2 is 1, negative 1. My y-coordinate of the vertex, I'll evaluate the function at negative 1. I have negative 1 squared plus 2 by negative 1 minus 8. So that's 1 minus 2 minus 8, that's negative 9. All right, so then putting that together, the vertex is negative 1, negative 9. All right, I can plot that point. There's negative 1, negative 9. How about the x-intercepts? X-intercepts. So let y equal 0. And we have to solve x squared plus 2x minus 8 equals 0. All right, now here we can try factoring. We can always use the quadratic formula, but I think this one does factor. Let's see, this factors as x plus 4 by x minus 2. That's 0, because 4 plus negative 2 is 2. 4 times negative 2 is 8, negative 8, so it does factor. So then set the factors to 0. X plus 4 equals 0. X equals negative 4. X minus 2 equals 0. X equals 2. So that tells me that my x-intercepts are at negative 4, 0 and 2, 0. Negative 4, 0 and 2, 0. And you know what? I think that's enough information to get a reasonable sketch of the curve. I know it's opening up. I've got the x-intercepts. So the function looks roughly like this. I've got the parabola opening up. That's enough for the curve. And we can find more points. We can add more detail, but I think that'll be sufficient. All right, so now let's solve x squared minus 2x minus 8 is greater than 0. We want to know where the outputs of this same, notice it's involving the same function. It's involving x squared plus 2x minus 8. We see that same expression in the inequality. We want to know where it's greater than 0. So we can literally think, where are the y values on the curve greater than 0? Well, I see that the y values on the curve are greater than 0 in this part of the curve, in this part of the curve. And so then that translates to this portion of the x-axis and this portion of the x-axis. And so x squared plus 2x minus 8 is greater than 0 when x is less than negative 4 or x is greater than 2. Now, we often will express that using interval notation, and so we could say that x is an element of the set negative infinity to negative 4 union to infinity. All right, now let's solve the inequality x squared plus 2x minus 8 is less than or equal to 0. All right, well, notice again we have that same x squared plus 2x minus 8. Okay, that same expression. And so we can literally think, where is y less than or equal to 0? And we see on the curve that y is less than 0 on this portion of the curve. That's sort of on the inside of the zeros. And y is equal to 0 at the x-intercepts. And so then x squared plus 2x minus 8 is less than or equal to 0 when x is greater than or equal to -4 and less than or equal to 2. That would be a symbolic form, or the inequality form for the solution. But again, we can write that using interval notation as x is in the interval bracket -4, 2 bracket.